Hello everybody, my name is Mike Guy, and in this video we are going to be looking at the Sprite Struct that we are going to make for our programs in Allegro 5. What I have on the screen here is some basic shell code. We have our timers, event queue. We load the sprite sheet demo, a sprite sheet that we created before. We create our window. We have some empty inputs, empty update, and then we just delete everything. So we're not really doing anything crazy here. This is just some shell code. And we are going to start off by creating our Sprite Struct. Now I do want to start by saying that normally I would use a Sprite class that has built-in functionality, but since we're keeping things simple, I'm going to use the Sprite Struct so you can see kind of how we can handle things in a simpler fashion, but still in a very powerful way using our struct objects. So I'm going to type struct sprite. Now our sprite is going to have many variables that are going to help us keep track of all of the different things that sprites currently have going on. So I'm going to start writing my x, my y as floats instead of integers, so we can allow for fractions of pixels. So my x and my y will be floats, and also my velocity x and my velocity y. I want to track how fast it goes in every direction, not just where it currently is. And then I'm going to have these variables direction x and direction y. And that's why I can just determine, is it going right to left or right, up or down or up, and we don't have to use these variables, but I'm including them so that, we can use them in the future if we want to. So that handles our positioning, our direction, and our speed. Next, we want to talk about animation. We're going to include all of this stuff inside of our Sprite Struct here so that we literally only need our single sprite object in order to handle all the different facets of its animation, of its movement, of everything. So I'm going to have int max frame for the maximum frames of animation, int curve frame for its current frame of animation, int frame count, and int frame delay to handle the timing. And then I'm going to have int frame width. And since the width of our image is actually going to be very large because it's going to be a sprite sheet, I have the frame width with it, which is just the width of the current frame of animation. And then I'm going to have int frame height for the same reason. And then I'm going to have int animation columns, which is just how many columns of animation is there on a sheet. And then int animation direction, which is something new here, and we'll see how that can be useful when we get to it there. Alright, and the last thing I want the sprite to do is I want the sprite to contain a pointer to its bitmap, to its own image. Now we're going to keep the sprite and the image separate, but we're going to have a pointer to the image of the sprite in the Sprite Struct. And the reason is this, is that let's say I had a comet, and I was keeping the sprite or the bitmap in the sprite object. Every time I had a comet, it would be a copy of that image. So let's say the image, and I'm going to seriously simplify, let's say the image, the bitmap of that comet was 1 meg, right? If I had 64 comets up on my screen, I'd have to have 64 megs of memory essentially set aside just for this one image, right? By keeping them separate, I can assign the same image to multiple sprites. And so now I can have 64 comets, but still only use 1 meg of memory. So I'm going to have the pointer to a bitmap, which is fine because we've been working with pointers to bitmaps this whole time. And I'm going to have that in there like that. And that's it. That is the Sprite Struct. It's going to give us lots of functionality, and it's going to be very powerful. And we're going to look at that here. Alright, so now that I have my Sprite Struct, I can go ahead and actually begin constructing a demo for you here. And so what I'm going to do here is I'm going to create a sprite object. So by typing sprite, I'm going to call this one dragon. Remember, we have that sort of dragon image that I got on the internet, and so we're just going to use that here. Now once I've created my object here, I'm going to go ahead and start assigning it some variables. I'm going to go ahead and initialize it. So I'm going to do dragon.x, and that's going to equal width divided by 2, and dragon.y is going to equal height divided by 2. Oh, I spelled height wrong. And then I'm going to do dragon.velocity x is going to equal 5. And I'm not going to assign a velocity y. Well, I could. Let's just assign a velocity y. In this demo, it's not going to move in the y direction, so I'll just give it a velocity y of 0. And then dragon.direction x is going to equal -1. -1 is going to move it from the right hand of the screen to the left hand of the screen. And then dragon.direction y is going to equal 0. Alright, great. So that's going to handle our positioning and our movement. And now let's talk about our animation. I'm going to dragon.max frame is going to equal 8. You'll remember our sprite sheet, there are 8 frames in that sprite sheet. Then I'm going to do dragon.current frame is going to equal 0. Dragon.frame count is going to equal 0, since we haven't started our animation yet. Dragon.frame delay is going to equal 5. And now we need to talk about our frame width and our frame height. Now I just happen to know this from making the sprite sheet, and when you make your own sprite sheets, this is something you're just going to have to know. And I happen to know that they are 128 by 128. Now, if my my sprite sheet had, let's say, 64 frames of animation, right? It could still only have 8 columns. So if max frame was higher than 8, I'd say like 64 frames, right? I would still need to tell it, hey, it only is 8 columns wide. It just comes down multiple rows. You can see we can use that with some math here in a little bit. In this example, the one we're doing right here, there's the same number of columns as there is total max frames. So this is going to feel a little redundant, but you'll see in future examples where we will have many frames of animation, but still only a few columns of animation, and the rest is just made up of rows. So I'm going to do dragon.animation direction, and that's going to equal 1. Alright, great. So that will initialize all of our variables except for one. That one is going to be our image variable, and we're going to initialize that here in a second. But that is going to initialize our animation and our positioning and movement variables. Great. Alright, so I load image as an Allegro bitmap into memory here, and I also have the destroy down here. And since I've loaded that into memory, I can now say dragon.image equals image. Great. So we are keeping the bitmap and the sprite separate. You can see the bitmap is loaded all by itself, but we're tying them together through this image variable. And that's it. Now we can begin actually using this. So everything's initialized. I'm just going to build it, make sure I don't have any typos. Build's great. Okay, so what I want to do is I want to add some functionality in that if I hit the left key, the dragon will continue moving to the left. And if I hit the right key, it will start moving backwards effectively. It's not going to turn around. I'm not going to bother playing around with the sprites like that. But it's going to move to the right, and also it's going to animate in reverse order to kind of make it look like it's backing up. Alright, so I'm going to come down here to Allegro key left. I'm going to say dragon.animation direction. I'm going to set that equal to 1. So it's interesting that if we're moving to the left, we are moving in the -1 direction, but we're going to be animating in the +1 direction, and vice versa. That's just, the way it's drawn. Of course, if it was drawn facing the right, then it would be -1 to -1, and so on and so forth. But with the way this particular demo is set up, our animation to the left is our 1 direction, and our movement to the left is our -1 direction. So I'm going to do dragon.direction x is going to equal -1. Great. And then inversely, I'm just going to copy this here. If I hit the right key, I'm going to say my animation is going to be -1, and my direction is going to be 1. Okay. So that's just going to handle setting some flags for us, and those flags are going to control how this dragon moves. Now in our update, there's a few things we need to do in our update here. We need to actually move our dragon, for one. We need to do some bounds checking, and then we need to update our animation. And I actually said that in the wrong order. I'm going to update my animation first. And so I'm going to say if, and you remember before in our previous example, our previous video, I did current frame plus or frame count plus is greater than or equal to frame delay, and that was all when we didn't have this struct keeping everything connected via one object. Now that I have an object, I can just say dragon dot frame count is greater than or equal to dragon dot frame delay. If that is true, then I'm going to go dragon dot current frame plus equals dragon dot animation direction. So what I'm saying here is this: is if, say, the first time around our current frame is going to be 0, if I'm animating in the positive 1 direction, if I'm animating across the sprite sheet, it'll then, current frame will then equal 1, and then 2, and then 3, and then 4. The cool thing is I can make myself back up. I can make myself animate in the wrong direction by setting animation direction equal to -1. And all we have to do is do a very simple bounds checking to loop it around in the opposite direction. So if you try to go down from 0, you'll come back around to its max frame. And we'll see that here. And I'm going to say if dragon dot current frame is greater than or equal to dragon dot max frame, then dragon dot current frame is going to equal 0. So we've looped around the correct direction. Now we've seen that in the previous video, but what we didn't see is this. Else if dragon dot current frame is less than or equal to 0, dragon dot current frame equals dragon dot max frame. Since it's a 0 indexed array, I have to say -1. Alright. Now you might be thinking to yourself, how does this work? Because at the beginning our current frame is 0, so we don't want 0, is less than or equal to 0 here, immediately changing our frame. And the reason this works is because this is an else-if animation. Alright? Since it's else-if, basically it allows us to test this one, and if this should we skip over this one here. So it actually works out well. And since it's only a single frame of animation that pretty much lines up any small jutting or skipping, if you will, goes pretty much completely unnoticed. Alright. And then finally I'm going to do dragon.frame count. I'm going to reset this to set our timing back the way we want. Our frame count is going to equal 0. Great. Alright, so that is our animation updating, and it's generic now. It's all just reliant upon these variables we set earlier. I can set them different ways, and it would animate different ways for different sprite sheets. Fantastic. So now what I want to do is I want to update its position. So I'm going to do dragon.x plus equals dragon.velocity x, how fast is it moving, times dragon.direction x. So it's going to move its speed in whatever direction it's currently going. And I'm just going to do a little bounds checking here. I'm going to say if dragon.x is less than or equal to 0 minus dragon.frame width. Then I'm going to say dragon.x is going to equal width. Alright, so if it moves beyond the left side of the screen, it's going to reappear on the right side of the screen. And I'm going to say else if dragon.x is greater than width, tight there, then instead dragon.x is going to equal 0 minus, because we want to offset it even further, dragon.frame width. Great. Okay, so now the animation is updating, its motion is updating, and we're doing bounds checking. Really, the last thing we need to do is we need to draw it. So I'm going to do AL, draw, bitmap, region, and I'm going to pass in our image, which is dragon.image. I'm going to pass it where in the sprite sheet we want to start, and that's going to be dragon dot current frame times dragon dot frame width. And then for where in the Y direction, since the sheet we're using is just a strip, I'm just always going to be on 0. We're going to look at the future, how we can change that for multi-tiers. But for now, just 0. And then I need to specify width and height. That's what I'm going to do, dragon dot frame width. And I'm going to skip down here so we can see this video here. I'm going to do dragon dot frame height. Great. And then I need to specify its final destination on our screen, and that's going to be dragon.x, dragon.y, and any flags, which I'm going to leave at 0. Great, okay. So what we have is we have completely generically programmed this, so the dragon could be any image, any number of animation frames or anything like that. So I'm going to go ahead and run it, and you will see, very much like we've seen in the past, right? The dragon is moving, but here's the cool thing. Watch, check this out. I'm going to go backwards, and it animates backwards. So it moves backwards and animates reverse, kind of like it's backing up. And that's pretty neat. I can just mix it up, change the things around. Okay, so that's our video on the Sprite Struct. And basically, all we're talking about is that thing encapsulation. Modularizing our code, treating it generically, grouping all of these variables together under one name, under one handle, so that we can make massive programs, with so many different objects. And in the next video, which is just going to be our Sprite Struct demo, you're going to see that. You're going to see me take, just this Sprite Struct. We're going to create an array of thousands of objects. You're going to see without modifying the code at all. All of a sudden we can just have as many of these as we really want. It's all handled generically for us by the program. So stand by. That is on its way.